Bismillahirrahmanirrahim. Hello everyone. In this video tutorial I'm going to show you how to design a masonry wall, or that masonry wall which is built or constructed from the concrete blocks. Let's see, here is some pictures. We have this picture, how we can configure this structure and how the size of this structure is. So the maximum can be 20 centimeters approximate or maximum, and also about 2.5 inches can be in direction be 1 meter. So it means each single blocks has 80 centimeters. So from center to this center it can be about 20 centimeters or more. And next thing is I'm going to show you sometimes we can embed some rebars inside to reinforce this kind of walls. So this wall is most of time for garage, for some sort of boundary structures, for also for partitioning and also other purpose. This is very common, and sometimes we can add a couple rebars inside of these blocks, and then we glued with masonry's material, so cements or some other material. Here is also some other pictures. Let's see. One thing I want to show you here is the in some part here is a sort of extra plates or extra members that can support as this load, the concentrated load of the truss elements. So this roof will transfer the loads, then transfer to here, and then transfer to wall foundation. And here is the parapet, and this is the parapet. In some case we will have here, like here we have some opening, so that opening can be in the bottom, like here door, and here like here wall. So then in the top of this we can provide a sort of lintel beam. Now we want to design such kind of wall because it's very common, and if you don't design properly, so there will be some failure or some sort of deficiency on the constructions. So we assume we have a wall which the pure height is 3.4 meters, and for designing of this sort of wall, each meter will take for the design, and then other part is properly the same as one single unit. We will provide a opening. This opening can be to a door, as a door, and also we can change it to be a window. At least with this time I want to be using a window 1.4 by 1.4 to times 1 to 1.6 meters, and the thickness of this wall want to be 25 centimeters. So the total thickness of the block is 20 centimeters. So other one both sides 2 centimeters is the oscillation part. We're using ASDIP software, and first give it a name called we can give a M, then M wall 25 centimeters. So I give a name this wall, and the next is I want to start open Here is the wall. The first thing we will face is the geometry. Uh, this is concrete wall. We are not expecting to design concrete wall, but we want to use a masonry wall. So the masonry wall is seems like this, the same we discussed previously, and this is one block which has two holes. There is option you can group one and also both. If using solid grouted, then all posts will be grouted using grouted, then calculate the materials weight. So it's better to use that empty, or use some sort of soft weight material that can reduce the weight of the foundation. And the first thing is we want the thickness. We have Propel 20, 25. That 25 is okay, and we want to use, there is two options. We can use two rebar, which I already show in on the pictures, and you can use a single. The single is enough. We can use D10, and it can be 20 each, one here, one here. If we're using 120, then it means we will use solid grouted materials in HO. So it's better to use 40, which is one is grouted and other is empty. That can reduce the weight. As much as the weight is softer, then the wall can be more resistant. And next is here we can use one stories. If there is required, we can extend to that. The parapet which are discussed is about 60, and the typical condition is one we using restrain this area and this area, so we can allow rotational, but we're not allowed translation. The opening is I want to give a opening in the middle of this wall here. Here is the opening. Let's see. I want it should be somewhat about 60 from the bottom of the floor, and the height should be about 160 and 160 by 60. I think I have given 100. That's better to use 60 by 60 as square walls. So this is done, and here is we can select number 1 and number 2 when we're using in the middle, so there is no need any kind of lintel beam. So if you use type 1, then it will require it will require a lintel beam. So in this case we don't provide a lintel beam. So in case if I used this kind of using type 2 or type 1, let me delete this, and type 2, so for this type this is the correct location of opening here. And next is the loading, the material. So we used a masonry with a strength of 10.15 megapascal, which is a soft concrete material with a strength of 0.70%. And so the nominal block weight can be 120 and also 140 cubic foot. And the yield strength is can be 60 megapascal, which is a low yield strength. And next we will go to the apply load. The load and the uniform load to the wall is 2550 kilonewtons per meters, and the concentrated load, which is taken from the roof, that can be about 56 kilonewtons, and the total uniform load eccentricity is it can be 0, so which we want to load should apply on the center, but it's not possible because a little eccentricity exists in such kind of wall. If you have been doing this kind of structure, you will put the structure that beams or still will comes to off of this beam, so there will be some sort of eccentricity. We can consider 5 centimeters, and this load can be 0, which we want to be at the top of the floor. And this is the concentric load spacing, which we want. It means we have a wall, and here is the primary or secondary beam which comes to the above of this wall. Here is a lintel beam, and it comes to above of this. So the spacing can be 1.2 meters or 120 centimeters, or it can be extended. It's based on your project. And the live load, we have 25 kilonewtons, and we have about 46, and the same we want for day load. So we don't have a roof live load, or we can take it about because if we're using that this first one is the same, and we're not equal. If it's second floor, then we can change it to because it's 2-story also built, so that's okay. I can give wind and snow is not required also with seismic. So just we have these two, and then we can write some name for who is charged of designing this. And here is the design part. So we have this geometry, and there is nothing is wrong, everything is correct. And from this geometry we will receive a pure normal force, axial force, and also maximum usable axial force, and also moment, so very large moment. And deflection is 0. This is deflection is 0, but we have allowable deflection 2.3 centimeters, and a pure tension is minus. So sometimes we will get in a negative direction. We will see in the later in the graph. This is the design part. We can see the first order analysis completed is okay. This interaction diagram, we can see the when we used that still have pure bending and pure shear same, and also so even this steel is didn't utilized, so we can go to back to see use D8, even this will be okay, and the pure shear will reduced. So, pure tension, so the tension is from the rebar which giving, and even we can use a T, so then it will be reduced. That means this rebar provide a tension resistance as well. So the interaction diagram has these properties. We can see pure compression is here, and from concrete, and total is here, and also from usable we have from concrete and from total, and the steel stress is here very high, and balance condition is, let's see, we have from concrete, we have from concrete moment and from normal, and this is the moment. So this is the interaction diagram, which is this material with this geometry is provided. And now we can go to see the detail it. Here is edge detail, is okay deflection properties using TMS timber masonry structure code 4.2. Each equation is cited and giving proper reference for verification. You can go and check it handy. And here is the opening design, pressure distribution, top bottom. So this is done, and the last one is the graph. From all the combination, it automatically selected a controlling combination, and that we can see the shear 1.5 kilonewtons per meters in the wall, and this is the moment with a large moment in the top, and the axial force, and the last one is the interaction diagram. So in a previous tutorial I've discussed, this is very important for understanding that you are giving loads and your column capacities. It can show you how your column has capacity to bear these loads. So this is the capacity curve, which has a maximum moment here and a maximum normal force here. But your load is in this region. So the wall is with this geometry quite stronger. So this is the end of the tutorial. If there is any question, please put in the comment and I will find time to answer your question. Thank you. See you next time. And one last things for reporting, just print report. And for saving, go to back to the geometry. This is already saved, and here you can save your model in any place you want, and this is called Masonry wall design. So here you can save, and this is done.